Hi, everybody. I just wanted to recap what we learned today a little bit for you. So remember that we have real numbers, and those are split into two flavors. Irrational, which are transcendental numbers like e and pi, and non-perfect roots like the square root of 17, and rational numbers. And rational numbers contain integers, which contain whole numbers, which contain natural numbers. And that, I think, we got because we've been working on that a long time. But, through all of our math classes. But there is a new couple kinds of numbers that you may not have a lot of familiarity with. Expanding on this idea of non-perfect roots, what's the square root of -1? If you think about it, you're trying to decide something that when you square it, you get -1, right? If you want the square root of -9, that's 3 because 3 times 3 is 9, right? That's what you're looking for. So you're looking for what number when you square it, you get -1. And try as you might, you won't be able to find that number. How can you multiply the same thing times itself? Inside these bubbles is some number and get -1 and the same number, okay, when you're multiplying them. So because that can't be done, I'm telling you right now, I'm going to make it be done. I'm going to call this number I. I'm going to claim that I times I is -1, this unknown number. I squared is -1. I gave this number this number a name and I called it I. The definition of I is a number whose square is -1. Now, some people just like to remember that I is the same thing as the square root of -1. But you really have to remember both of these boxes. I squared is -1 and I is the square root of -1. And that's imaginary. So what I'm saying is, you know what the real number looks like. Real number line looks like. And so I'm going to take us down here. Technology. Here we go. Okay. So you know what the real number looks like. 0, 1, 2, 3, 4, -1, -2, -3, ... right? Now, what if I took that real number line and made a new number line and called it imaginary and intersected it with the real number line at right angles? 1, 2, 3. These have eyes on them. -I, -2I, -3I, ... So now I've got this imaginary number line too, composed of multiples of I. So this is what I call the complex number plane. And the reason why I call it that is because all numbers can be pictured on it, because all numbers are complex numbers. Any number I can think of, real or imaginary, real and imaginary, is a complex number. This number, 2 plus 3i, that's not two numbers, that's one number. That is a complex number. Its real part is 2, and its imaginary part is 3i. If I was going to graph it, I would graph it right here. 2 on the real, 3i up. There it is. If I were to graph it on the complex number plane. I is a complex number. It has no real part and one I imaginary part. So if I was going to graph that one, I would graph it right here. The number 5 is complex. 5 is the real part, 0 imaginary part. If I was going to graph that one, I would graph it right here, 5, on the real number line. Any number you can think of can be graphed on the complex number plane because all numbers are complex numbers.